Hi, Mr. Unkert here, and I'm reviewing the Khan Academy assignment Finite Geometric Series. So we're going to use the geometric series formula to solve these problems. Um, and let's take a look at this first problem. It says geometric sequence a sub I is defined by the formula a sub 1 equals -4 and a sub I equals a sub I minus 1 times 2. Okay. So to use this geometric series formula, just as a reminder, is going to be the sum of n terms equals the first term times 1 minus common ratio r raised to the nth power divided by 1 minus common ratio r. Okay. We have to identify these things. So the first term is going to be -4. The common ratio, since we're multiplying by 2, is going to be 2. Okay, the number of terms is going to be 50. So I'm going to plug those in. -4 times 1 minus 2 raised to the 50th power over 1 minus 2. I'm going to take out my Android calculator to do that. Just take that out. My Android phone, which is what I'm using. So, put it out here. -4 times 1 minus 2 raised to the 50th power, close that parentheses, divided by, in parentheses, 1 minus 2. Okay, and I'm going to show you what I get. So I'm going to get, let me write it down here so you can see a little bit more complete. -4.5035. And then there's 99627. Then the way my calculator writes it, there's an E, and then a 15. Okay, so what the E means is times 10 to the 15th power. And if we round it to these two terms, 4.50, we have a 3 after that, so that means I keep the 0, I don't round up to 1. That's -4.50 times 10 to the 15th, which is solution B. Got some energy points, it's a good day. All right, in this one, we have some summation notation. So we have the sum from the 0 term to the 19th term of this expression here. So we have to kind of decode what this is. So -4, that is our first term. The -2 here is our common ratio r. So r equals a -2. Actually, my r is not very good. That looks more like a v. Let me fix that. So again, r is -2. And now you might think the number of terms is 19, but it's not. It's actually, since it's starting at 0 and going to 19, you have to include the 0. So the number of terms is actually 20. If, however, you were starting with k equals 1 and going to 19, then n would equal 19. But since we're starting at 0 and going to 19, the number of terms is actually 20. Okay, so we're looking for the sum of 20 terms. And that's going to equal the first term, -4, times 1 minus, I'm going to put the -2 in parentheses, -2 raised to the 20th power. And I'm going to divide that by 1 minus -2. And we'll see what that is equal to. So let's, I'm going to use my handy iPhone camera. Or I have an Android phone calculator, not camera. Haven't had my caffeine yet this morning. And finish that up. Okay, and when I enter this into my calculator, I get 1,398,100. I get this answer. Okay. Way to go. We got some energy points. Keep going. The next question. Okay. So we're finding in this one, we're going to find the sum of the first 25 terms in this geometric sequence. So we already have n equals. We know the first term in the sequence is 8. So 8. And to figure out the common ratio, we're going to take this number and divide it by the first number. So take the second number divided by the first number. So r equals 6 divided by 8, which is 3/4 or 0.75. Okay, so now it's just plugging in to the formula. So the sum of 25 terms equals the first term 8 times 1 minus 0.75 raised to the 25th power over 1 minus 0.75. All right, I'm going to take my calculator, figure out what that is. So I have 8 times 1 minus 0.75 raised to the 25th power. I'm going to divide that by 1 minus 0.75. And I get 31.975. The 5 is after the 7, so I'm going to round that 7 up to an 8, and I'm going to get 31.98 as my solution. That, more energy points. Let's see if we can get a perfect score. Move on to the last one. Okay, we're going to find the sum of this geometric series. So we're going to start identifying some things. Let's start identifying A, the first term. So A is going to be 1. Common ratio is going to be the second term divided by the first term. So common ratio R is going to be 1.2 divided by 1, which is just 1.2. And then you may think we only have 74 terms here. But Really, this is 1.2 to the first power, and this is 1 times 1.2 to the 0 power. So we actually have 75. So n is 75. Let me see if I can fix my n. But so again, n is 75. So we're looking for the sum of 75 terms. So it's going to be our first term 1, 1 minus 1.2 to the 75th power over 1 minus 1.2. Okay. So if I do that in my calculator, do 1 times parentheses 1 minus 1.2 raised to the 75th power. Close my parentheses, divided by, in parentheses, 1 minus 1.2. Okay. And I'm getting 4,340,731.846. Since the 6 is after the 4, I'll round up to 5. And it looks like D is going to be my solution. And look at that. We've got perfect score, perfect energy points for this activity. I hope this video helped you. If you have questions, please leave comments in the comments below. Otherwise, thank you for watching and have a great day.